Let's see the next page replacement algorithm, that is optimal page replacement algorithm. Okay, so optimal page replacement algorithm, it will never suffer from Belady's anomaly. Okay, so here we will replace the page that will not be used for longest period of time. Okay, so OPT guarantees that there is lowest possible page faults. Okay, which will having lowest possible page faults. Okay, so what is the criteria? We will replace the page which will not be used for the longest period of time. Okay, so we will take the same page reference string, that is size equal to 20. Okay, now how to do this one? If there is a free frame, we will replace it. Okay, 7 and followed by 70, second page fault, and followed by 701. So now the main memory is full. Then it comes to 2. Okay, now 2 will be replaced one of these pages. 2 will be replaced one of these page. But which page will be replaced? Let's see. First check the count for 7 where it is coming. Okay, so 0 and 1. 7 is coming 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15th place. Okay, the distance is 15. But look at here, there is 0, that is immediately will be there. Keep 0 here. Then 1 is before 7. 0 and 1 before 7. So we are not replacing 0 and 1, we will replace 7. We will replace 7. Similarly, look at 0. 0 is already there. Okay, and 3, when you need to replace 3, because 3 is not present here, we need to replace 3. Which among these will be replaced? Okay, now look at here. First start from 2. 2 1 2 3, third place. So 2 you cannot replace, so keep. And 2 1 2, third position. Immediately after 3 there is 0, so you cannot change 0 and 2. 0 and 2, so I am writing 0 and 2. 1 is far away from this particular 3. 1 is very far from this particular t. So before 1, 0 and 2 will be there, so write 2 0 in place of 1, write 3. Now let's check 0, there is no page fault. Now check for 4. Now check for 4, which one of this one will be replaced? So after 4 there is immediately 2. Okay, na? So I will take 2 here. Okay, after 2 there is immediately 3. So 3. So there is only one option that will replace, that is sorry, there is one option that will be left, that is 0. So keep 2, keep 3 in place of 0, add 4. Okay, now 2 is already there, 3 is already there. Now we need to check for 0, because 0 is not present. So 0 has to be replaced. When 0 will be in which place 0 will be replaced? Let's see. From 0, look at here, 3 is immediately after 0, so write 3. Okay, then after 3 immediately there is 2, so do you write 2. So in place of 4, write down 0. In place of 4, write down 0, because 0 is 4 is the longest and it is not referenced again in the coming future. Okay, now look at here, 3 is already present, 2 is already present. Okay, no page fault. And let us see for 1. 1 has to be replaced, any one of this one, 2 0 3. So from 1, look at here, immediately there is 2. So 2 will be kept as it is. Then the next one will be 0. So 0 will also be kept. And 3, there is no near future, 3 is coming. Okay, so we need in place of 3, write 1. Okay, now it is 201. Now it is 201. Now look at 2 is replaced, 0 is replaced. See, 2, there is no page fault because 2 is already there, 0 is already there, 1 is also already there. Now come to 7. Now come to 7. 7 is not present in the main memory, so we need to replace 7. But which one will be replaced? Now look at here. Immediately there is 0, so I am keeping 0 here. Then after 0 there is 1, so I am keeping 1 here. So in place of 2, I am replacing 7, and 0 is already there, 1 is already there, no need for page fault. Now count the number of page faults. There is 1, 2, 3, 4, 5, 6, 7, 8, 9. The total number of page faults, that is, okay, page faults occur is 9. Okay, that means 9 times we are replacing the page. So by using optimal page replacement algorithm, we can have 9 page replacement algorithm, which is very lowest when we compare to FCFS, that is 15 page. Now let's see the problem with optimal page replacement algorithm. Here, the optimal page replacement algorithm is practically impossible. Practically impossible to implement. Okay, which is difficult to implement. Why? Because the optimal page replacement algorithm needs future knowledge of reference string. That means we need to predict which frame will be referenced in the near future. So that's a difficult task. That is a difficult task. But still, why we are using optimal page replacement algorithm? It is a theoretical concept. Okay, it is a theoretical concept. The number of page faults that comes with optical page replacement is 9, which is very low. Okay, so we'll use this particular optimal page replacement algorithm for comparison of different algorithms. So which any algorithm which comes near to OPA number of OPA page faults, okay, that will consider it as a better algorithm for that particular scenario. So this particular OPA is used for performance studies, system performance studies. Okay. Let's see one more algorithm called least recently used page replacement algorithm. Okay, so here the criteria is the page that has not been used for the longest period of time, okay, will be replaced. So which one will be replaced? The page that has not been used for a longest period of time. This needs past experience, okay, not future. It is past experience. That means when a page was taken into main memory and when it was used last. It will be when it was used last. Okay, right. So let's see how this particular algorithm works. Same page reference string, the size of the page reference string equal to 20, and we need to find the total number of page faults that will be coming. So first, the size of the main memory is 3. I will add 7 because it's free. 7, 0, it is also free, frame is also free. First 3 frames, I will get 3 page faults. Okay, now from 2 is not present in the main memory. 2 is not present in the main memory, so I need to replace one of the pages with 2. Now which page will be replaced? From 2 we need to look at left side. We need to look at left side. If you look at the left side, 1 is the most recently used page. I will keep it here. 0 is the next most recently used page. I will keep here, and there is only page that is left, 7. Okay, so 7 will be replaced with 2. As 2 will be replaced with 7. 7 will be replaced by 2. Now let's look at this one. Next page reference equal to 0, which is already there, so no page fault. Then I need to 3. 3 is not present here, so I need to replace this particular page. I need to find a victim page. So how to find? Let's from 3, the next one is 0. Okay, the previous one is 0. I am keeping it as it is. Then before 3, it is 2 referenced. So 2 0 will be as it is. In place of 1, I will write 3. Okay, so next one is 0. There is no page fault. From 4, look at from 4. 4, the next one is, the previous one is 0, so I am keeping it. And before that there is 3, I am keeping it. In place of 2, I am replacing with 4. Okay, again from 2, 4 is there and 0 is there. In place of 3, I am replacing 2. Okay, again 3 is coming. Which one to be replaced? Previous is 2, before that 4. So 2 4, 2 and 4, I am writing it, and 3 will be replaced in place of 0. And again there is a 0 which was recently uh, replaced. Now 0, 3 and 2 will be kept. 3 and 2 will be kept. In place of 4, 0 will be replaced. Okay, again 3 which is already there, 2 which is already there. Now we need to replace 1. Now we need to replace 1. So 2 and 3 which was recently referenced, see, we are not looking at the first process, that first page that is loaded. We are looking at the recently referenced. So 2 and 3 will be on their places, and in place of 0, 1 will be replaced. Okay, now 2 is already present in the main memory. so no page fault. Now let's look at 0. 0, from 0, the previous one, that is 2. Okay, before 2 there is 1, so in place of 3 we'll replace 0. Okay, now look at this one. Next one is 1, which is already present, no page fault. 7 has to be replaced, okay, with one of this one. So if 7 has to be replaced, the previous one is 1, I am keeping it. Before that there is 0, I am keeping it. So 2 is the least recently used, so in place of 2 I am writing 7. It is 107. Then 0 is already there, 1 is already there. Okay, now look at the total number of page faults: 1 2 3 4 5 6 7 8 9 10 11 12. The total number of page fault that comes is 12. Okay, so least recently used with the same reference string, we got 12 page faults. Okay, so with least recently used we got 12 page faults. Open page replacement algorithm we got 9, and FIFO we got 15. So least recently used is came near to open page replacement, that is optimal page replacement algorithm. Okay.